Hello friends, welcome once again to YouTube channel Tech Guru Gautam Prasad, and here we are going to discuss star delta transformation or delta star transformation. This star delta transformation or delta star transformation is basically changing a star connected set of resistances or impedances into delta connection or delta connection into a star connection. So this is a vice versa kind of conversion or transformation. Uh, it is needed because uh, we want to minimize the mathematical activity when we are doing the calculations in the uh, network analysis. So in a set of uh, passive elements connected in an electrical network, when you are doing calculations or analysis work, a lot of mathematical derivation is involved, but this star delta conform transformation or delta star transformation helps you in minimizing the mathematical work involved. So let us see what is it. This star connection is also sometimes called Y connection, or delta connection is also called delta connection. It is also called T connection. A star connection is also named as T connection. As you can see here, this is connected in T fashion, T network, and the same thing can be redrawn into a star looking network. Also, you can see this pattern, which is called pi network, is connected, and this could be, redrawn into a delta network. Now, thinking if we have a star connected network or delta connected network and we want to change it to another, like here, there are three terminals, 1, 2, and 3, and A, B, and C are the impedances connected in delta fashion, and we want to change it to a star connection between 1, 2, and 3. The terminals remaining the same, and between those three terminals, we are wishing to connect it in a star fashion uh, and not delta fashion as it has been shown here. So when you want to do that, you will have to do certain calculations, but that becomes a formula at a later stage, and you can take the help of this formula every time you wish to do this transformation. So here it is how it is done. If you look at the terminals 1 and 2, 1 and 2, then P plus Q, these two resistances are in series. So you can write P plus Q. And if you look at the two terminals 1 and 2, you will find B and C are in series and they have been placed with A in parallel. So here it is written A is in parallel with B and C. A is in parallel with B and C. So, thinking that A is connected in parallel with B plus C, you want to calculate the effective impedance, then you multiply these two impedances and divide it by the sum of the impedances. So that is what it has been done here. So P plus Q becomes equal to A multiplied by B plus C divided by A plus B plus C. In the similar fashion, if you look at the terminals 2 and 3, you will get Q plus R equal to C into A plus B divided by A plus B plus 3. This is equation number 2. Earlier one was equation number 1. Resistances similarly between 1 and 3, if you look at, this becomes this leaves you with the equation P plus R equal to B into A plus C in bracket divided by A plus B plus C. So if you subtract, equation number 2 from equation number 3, you will get P plus R minus Q plus R. And if you solve this, you will get P minus Q equal to BA minus CA divided by A plus B plus C. And similarly, if you rewrite equation P plus Q will be equal to AB plus CA and this. So if you add these two equations, this one and this one, then you will find, like P plus P minus Q plus P plus Q is equal to this Q, and this Q will be cancelled out, and 2P will be equal to, this implies that sign should be there. So 2P will be equal to 2AB divided by A plus B plus C. So 2 will be cancelled once again. P will be equal to AB divided by A plus B plus C. So when you are P is equal to AB divided by A plus B plus C. Remember this one. P is equal to this. P is the resistance of the star connected network. P is equal to P. If you keep this P between terminal number 1 and terminal which is common terminal of the three resistances in star, then you get it is equal to uh, this A into B divided by A plus B plus C. So A into B divided by A plus B plus C. This is the formula. Look at this. We had derived AB into AB divided by A plus B plus C. So A and B are two resistances falling. If you place this whole thing here between terminal 1, 2, 3, then you will find, in order to find this resistance, you will have to multiply these two, and you will have to divide the product by the sum of these three resistances or impedances together. Right, so that is the formula. That is how you can keep it in your memory. That is very important, and we teach this to the students who are learning afresh. The first time they are learning, we help them in memorizing this formula, because we ask questions based on these transformations. All right. So Q is with the similar fashion we can yield the equation for Q. Q is equal to AC divided by sum of A plus A, B and C. R will be equal to BC divided by sum of A, B and C. So you get a formula for P, Q and R. Uh, these are P, Q and R are resistances or impedances of a star network, and A, B, C are the impedances of delta network. So this is the formula for delta 2 from delta to star transformation. In the similar fashion, if you want, here is a question basically. So you have been given the values of A, B, and C, and you have been asked to calculate the values of P, Q, and R. So having got the values of A, B, and C, and you can calculate based on the formula above discussed. So P will be equal to AB divided by sum of ABC. 20 into 30 divided by 1 and 30 becomes 4.61. Q will be equal to AC divided by sum of ABC, and that is equal to 20 into 80 divided by 130, 12.31 ohms. R will be equal to BC divided by sum of ABC, and that is equal to 30 into 80 divided by 130, and that calculates to be 18.46 ohms. Now coming to a star delta transformation. So when you have impedances connected in a star fashion and you wish to transform it to delta connected impedances, the terminals remaining the same, 1, 2, 3, 1, 2, 3. The names of the impedances have been changed for identification purpose. P, Q, R are the impedances of star network, and ABC are impedances of uh, delta network. You can call impedances to be resistances for the purpose of solving. These impedances could be impedances or resistances, or combination of the passive elements, as we have discussed in the earlier videos. Capacitance, resistance, and inductance. So this could be combination of any of the three passive elements. So here, if you look at A will be equal to, for this A is the terminal between uh, 1 and 2 terminals. Between 1 and 2, A is the resistance. So if you want to calculate the resistance, the value of A, then you will have to multiply uh, these three together. You have to take the sigma of a P and Q. That means PQ plus QR plus PR. So you will have to sum all them and uh, divided by R, this resistance. So sigma of PQ divided by R, this branch. This will be the formula. So in order to calculate A, you will have to multiply PQ plus QR plus RP divided by R. So that is going to be your value of A. That is delta impedance or resistance, right? So here is the formula for B and C in the similar fashion. Okay, so the whole formula for this becomes like this. A is equal to PQ by R plus Q plus P. You can resolve it to, if you divide it by P, this will yield Q plus R divided by QR by P. So it is like this. You can write it in this fashion also. A equal to PQ by R plus Q plus P. B equal to RP by Q plus P plus R. C equal to QR by P plus Q plus R. So QR, Q plus R. RP, P plus R. PQ, P plus Q. The similar fashion in this I pointed out to uh, help you in memorizing all these formula so that you can help them. Here is a example. You have a star connected resistances, and you have to transform it to delta. So for that purpose, you can use this formula. A equal to QP by R. A is equal to QP by R plus Q plus P. Q plus P. So add Q plus P and then add QP by R in that, and you will get the value of A. Similarly for B, RP by Q plus R plus P, and this will give you the value of B. C equal to QR by P, Q plus R, and calculate the values. After substituting the values, you will get their respective values. So this is how this transformation takes place, and this is very helpful in solving network related problems, electrical network related problems, or electronics network related problems. In both the types of analysis, this star delta transformation is quite useful. I hope you loved learning this star delta transformation or delta star transformation, and you will appreciate this video in your comment, definitely. Thank you very much for staying tuned with me. Be with me. Keep on watching my good videos and keep on suggesting your good points. That will definitely help me bettering this video. Thanks a lot.